So first, let's do some introduction to JavaScript, right? So as you know, JavaScript is considered to be the programming language of the web. That's where it has most shined, right? It was created by Netscape, right, in the early 90s. And the intention was that we wanted to be able to have a program, right, that could execute inside of the browser, right? So as we know, we can use plain old HTML and CSS to create static content, right? That we can specify the content using HTML, use CSS to style it. But those are two separate languages, right? HTML and CSS. They're both declarative languages in which they declare content to be of a specific type, right? That declare certain things to be heading, and then CSS also declares saying that certain things should be red, green, blue, certain size or position on the screen. But they lack some fundamental features such as being able to create abstractions using functions, right? Factorization, so you can't, create algorithms, right, that can execute over a data structure, that can iterate, right, or compute things. So there's no functional programming at all, right, in HTML or CSS. So you can't compute content. So JavaScript, well, the intention was that we could take the DOM that is created by HTML and CSS, right? Take that data structure that gets created in the browser. We can come back then with JavaScript and we can programmatically manipulate that data structure. And manipulate the data structure, we can effectively manipulate the user interface, right? We can add content, we can remove content, we can switch content around, right, and implement navigation, right, and so it became a very powerful tool for web developers, right, that we could manipulate this user interface much more powerfully, right, as opposed to just declaring the content. We can now dynamically compute the content. So the way it works is that in HTML, right, you have different tags that declare content, like headings and tables and lists and whatnot. So they added a new tag called script, right? And this script allowed you to embed code inside of the opening and closing tags, right, of the script. So that inside of the body of the script tag, you can have functions. You can call functions. You can create new functions. You can implement algorithms, right, that could manipulate the document object model, the DOM, right. So here's an example of the simplest of JavaScript programs. Here's an alert, right. If you embed this inside of an HTML document, right, it would pop up a little blurb, right, a little dialogue. And now this is a raw JavaScript, right, the lowest level JavaScript, right, that you would embed directly in an HTML document. Now we're not going to do that. Right? This is very low level, right? It's almost like me talking about maybe assembly language, right? Right. It is a language that at some point we did use. This is still widely used, right? But today most developers, web developers, don't directly, code insert their code in HTML documents. Instead, they use abstractions such as Vue.js, React.js, right? You can still definitely embed script tags inside the index.html or other HTML documents, right? And this would totally work, right? But again, that's more legacy. Today instead we use higher level abstractions, again, such as React.js. Nevertheless, I'm going to review that. You should know about it, right? You should be familiar with it, even though you might not actually get to use it at all, right? Maybe once in a while, right? That you might need to do something like this, such low level. So here's a few other things that you can include in a script tag, an alert box. You can do a console log, allows you to print to the console, in a browser, right? If you look at the web dev tools, right, that we have been looking at, right, we looked at the elements tab, right, that allows us to see the DOM, right? There's also the styles tag that allows us to see the CSS. Today, we're going to introduce a new set of tabs in the DevTools, right, that are going to allow us to see console, right? These programs that are running in the browser, right, they could print out, values to the console, and they're useful, for debugging, right? Where you can print out where you are in which line and what function and whatnot, or data to the console. Another very powerful, for which is much more mostly known JavaScript, is that there is this document global variable called document, right? And this global variable or global object instance, right, is it contains the API, right, that allows us to interact with the browser, right, to interact with the DOM, right, the DOM data structure, right, that is the hierarchy that gets built in that the browser uses to then render the user interface, right? You can manipulate the DOM using this document object, right? And in there, you have all sorts of functions in there, right? One of the most common functions is the write function, like this, document.write. This allows you to add to the DOM, right? If you keep writing, all that content gets appended, right, to the document object model data structure, and then and by extension, right, drawn on the screen, right? Now you can write just plain text like this, or you can write HTML snippets, right? And that snippet will be added to the DOM, right? Will be parsed, right, and then added as an instance object node, right, in the hierarchy of the data structure. So I'm going to illustrate, demonstrate just a few of the key uses of the document object. Again, this is not. I'm not going to ask that you be able to do this at all, right? Not in this course anyway, right? But nevertheless, I just want you to be aware of it, as a legacy, right? That we have inherited, and we kind of want to know what is the what is the magic happening underneath, right? So not only can you write to the DOM, but you can also read from the DOM, right? And so the DOM, you can have unique IDs. These unique IDs declaring ID attributes with the values, right, all throughout different assignments. Well, you can read content, retrieve content from the DOM by their primary ID. Right? So you can say the ID, and here you can grab it. You can say, well, get me the element, the node from the DOM, right? Give me that node in the DOM, right? Grab it by its ID. And what this will do is that it will start at the root of the DOM, right? And navigate, traverse this hierarchical data structure looking for the item, the node, right? Whose ID is hello, right? Once you have an instance of this object, there's a whole bunch of properties that you can manipulate. For instance, if it's a div or paragraph, well, there in the body of the paragraph, there's text, right? And so you can override what text is going to be displayed in that paragraph, right? Or you can append content inside of an element. You have an element that you can put content inside of that element, right? Could be text, it could be more HTML. So for instance, if you have a UL, right, the UL contains line items, which is again HTML. So once you have a node, you can say, okay, well, I want to override, I want to write inside of the body of that element, right? And I want to put some content, right? So you can write into the body of the element. So here's an example of having a header of a and then the document.getElementID grabs an instance of this heading, right? And then it can write to the content of that header. Okay. This script is grabbing an instance to that little header here, and then you can write the HTML content, the text content. You can override also the look and feel. There's all elements have a style property that you can override the look and feel. So you can change the CSS properties of the node, right? So color, you can make it red. The font size, you can make it 25 pixels, right? So again, this is very, very low level, right? You can change its display property to none, so you can hide it, right? Okay, you show it again to block, right? So you can also work with different data types, right? That are provided natively by the language. One of the data types new data type that we're introducing today is the date data type, right? So the date data type, you can create new instances of these data types, right? There's several data types. There's number, there's string, date, there's Boolean, right? So you can create instances of these data types, right? And then these data types, right? The instances of these have functions that allow you to manipulate different parts of the data structure. For instance, you can get the month of the instance. So by default, when you create a new instance of a date, it has the current date, right? It looks at the current server machine that is running on. It queries the operating system, what the date is, and then instantiates the date object. Again, this is all running inside of a browser, right? Instead of an HTML document. And then you can, for instance, write the month of the day. You can write the full year. You can also work with arrays, right? Using the square bracket syntax, where you can have different values with commas, right? And then you can spit it out and print it into the HTML document. And it renders just like that, right? With brackets, commas, and whatnot, and the numbers. And here's an example of iterating over those scores, right? And then calculating the total average, right? And then spitting out the computation on the screen. Again, just illustrating, right, that we can write algorithms, right, that can compute content dynamically, right? And as opposed to creating things statically using HTML and CSS. Here's another example of, now that we have the scores as an array over here, we're going to display as a list. So we can write HTML, right? So this would add a UL element on the DOM, right? And then you can then print several line items, right, that contain the scores, right, displaying the different scores in the array, right? And then you write the closing UL. So this whole writing, right, to the DOM, it's as if you've written this manually, right, in the HTML document, right? But the whole point here is that we want to be able to do this programmatically, not manually, right? Because either the work is too big, right, is overwhelming, and we want to break it out into smaller pieces, right, and into manageable pieces that might be reusable, right? So JavaScript allows us to use functional programming, right, to compute the user interface. Here's another example of displaying the same content, but in a table, right? So here we were writing each individual content right away. So document.write UL, document.write li, closing li, writing the. Or instead, another approach is to compute an entire string first, right? So you concatenate a very long string, and then once you have the entire string computed, right, you write it only once. That's another strategy, right? So for instance, here we're computing the string starting with an opening table, right? And then we are appending the table row, right? And then we're appending a TD for each one of the columns, right? And we're iterating over the scores, right? With one row that has many, many columns. For each one of the scores, we add each one of the rows, right? And then at the end, we close the table, and now we have this table being a very long string, right? That has the opening table, the rows, the table data, row, table data, row, and then at the end, the closing table. So we have this really, really long string, and then we just write that one string to the document, and boom, it displays the table on the screen. Okay. We also have event handling, where you can click and interact with input fields, buttons, things like that, right? And you can associate functions that get executed when you click on these buttons, right? So they could run some algorithm, add content to the screen, remove content from the screen dynamically, right? So all that we're going to be learning throughout our JavaScript coverage. So here's a function. You can declare functions, and then you can invoke them right from clicking an object or button or anything's clickable in HTML, right? Not only buttons. Mostly buttons, you want to make them clickable, but really any element could be a button. Instead of embedding the code right inside of the HTML document, right, a better approach is to move all the code into a separate file, right? So for instance, we could move all these functions and algorithms that I've shown you so far, right, and just move it into hello.js, right? And then you can import those into your document. Now, typically, the importing of all these JavaScript files is done at the head of the HTML document, but oftentimes you'll see developers actually loading these files at the bottom of the body. So even though this is syntactically incorrect, right, it's a very common practice since these files could be pretty big, right? They could be libraries. It could be the jQuery library. It could be the React.js library, right? And so these take time to download, right? So you want to make sure that you're minimizing the time that users see something on the screen, and then from us, computing or running some functions and things like that might take away from the time that the user sees something on the screen, right? We want to minimize that time, right? So downloading these big files might take a little while. So oftentimes, developers will put it at the bottom of the body. So here's a couple more examples on implementing a little calculator where we have here an input field where we can read the value of the input field, right, by grabbing a reference to the input field by its ID and then reading the value of the input field. So if you have typed something in the input field, we can read it, right, using the elements.value. So for instance, if we want to implement a little calculator, we might have two input fields, A and B, and then we could have several buttons, right? But that would add A plus B or multiply A plus B times B, subtract or divide, right? And so each one of these functions could read the values that you had typed into these two input fields, compute the value of adding or subtracting, of multiplying or dividing, and then writing, right, the inner HTML of the span with that, which has the results, right? So here you have add A plus B, right? It's grabbing each one of the values, right, of the input fields A and B, parsing them into integers because whenever you read from these input fields, the default is that these are all strings, right? So you parse them into an integer, just make sure that they're integers, right? And then we add both of them, right? And we update the inner HTML of the C span, right? Also today we're going to introduce JSON. JSON stands for JavaScript Object Notation, right? And it's a very standard syntax for declaring and working with objects, right? Formatted for JavaScript. There's the native format or syntax for working with objects, arrays, and things like that, data structures in general in the JavaScript language. And basically, it consists of declaring multiple properties, right, inside of a curly bracket, right? And each property can be given a value using this colon syntax. So you say property colon and then the value. Now all these values right now are integers, right? They're whole numbers, but they, each one could be a separate property. Another one could be an integer. Another could be a Boolean. It could be another nested object, right? So objects within objects, or it could be arrays in there, right? Or arrays that contain other objects that contain other arrays. So you could have, arbitrarily complex data structures, right? That represent some kind of state information inside of your application, and we'll get to work with that quite a bit. And then once you have the data, you can then use the dot notation, right, to navigate through the data structure in each one of the properties and sub-properties, right? So following this dot notation. And so here's an example of navigating through the house object. So we call this an object literal right? Just like 3 is an integer literal, right? It's literally the value 3. This curly bracket syntax, we call it an object literal, right? It's literally, we give you the properties and the values right there. So we're not like instantiating or calling some function that calculates this, right? We are literally giving you the value of an object right there, right? And then we're using the dot notation to, populate some user interface, right, with the inner HTML and elements that are in the HTML document, right? Strict, this was early on when JavaScript was still not very mature, right? And it allowed us to do certain things that are somewhat frowned upon today, right? For instance, you were allowed to use a variable before you declared it, right? And there's certain things like that. For instance, also the use the equal sign, right? That is not very strict. Like it compares whether the two values are sort of the same, right? So for instance, the character 1, it is equal with the numeral 1, right? And you must say, well, why? Well, because you cast one to the other, right? And so you can sort of say that they're the same, but they're not, right? So we discourage some of these early issues with the language, right? And so one of the earliest solutions to this was to use this string at the top of each one of the files, the JavaScript files, would tell the browser to be much more strict about not allowing doing some of the more dangerous things with the language, right? That were very error prone or made it easy to create bugs, right, and harder to debug. So Ustring was the earliest solutions to this. Today, we don't have these issues because we're using a much modern version of the language. We're using ES6, ECMAScript. Also, the official name of the language is not JavaScript at all. It's ECMAScript, right? And so we're going to be using the latest version of ES6 of ECMAScript, right? IIFE, this was one of the earliest approaches to creating modules. And one of the biggest complaints with the JavaScript language was that there were no namespaces, right? Just like, in other languages, Java, C#, right? These are, you can declare packages and variables or functions or classes that you declare are typically declared inside of a package, right? And they're not accessible globally to anybody, where not in JavaScript. Everything was global in JavaScript. And so that made it very, very error prone, right? Very easy to write buggy code. And one of the solutions to this issue was to declare everything in a function, right? And variables that are declared inside of a function, those are hidden from prying eyes outside of the scope, right? So we could use functions for creating scopes, right? So again, this was a hack early on in the language. We're no longer going to be using this technique. All right, let's move on and talk about some more modern versions of the language. So let's talk about ES6. So ES6 is a turning point in the history of the JavaScript language. In 2015, there were major updates to the language, right, that address many of the glaring problems with the language, including modules, the lack of scoping, right, and introduced many improvements on how to work with variables, constants, functions, the keyword this, right. So let's take a look at first at some of the newer properties or features of the language, including variables. So variables was one of the first things that they addressed. So for instance, the earlier versions of the language only had the keyword var, where you can declare variables, right, with the keyword var. And this syntax allowed something pretty weird, where you could use the variable before you declared it, right? So with the newer introduction in the latest ES6 language version, these two new keywords were introduced: let and const, right? And we advise you to never ever use var ever again. Instead, to use these two new keywords, let and const. So let, one of the cool things is that it doesn't allow you to use a variable before you declare it using let, right? So it's much better. Constants obviously make things that can only be given a value at declaration time, and you cannot change, right? Before we didn't have constants, right? So that's great that we have those two new keywords. JavaScript object notation, we discussed that a little bit. And so here's an example of an arbitrarily complex JSON object, right, called some object that starts right here in the opening curly bracket and ends here, right here in the closing curly bracket, right? And in there we have, let's see, 1, 2, 3 properties, right? An object property, a number array. So those are 3 properties. So here's a simple one. So array property, meaning the value is an array, right? Again, the names, I just made up the names, right? But it could be any name you want, right? So when we call these the properties, okay, and then you have the values on the right-hand side of the colon. And the properties could be other objects, could be arrays, right? Or arrays that contain objects. So you can intermix, right? Objects that contain arrays, arrays that contain objects, and a mixture, arbitrarily complex mixture of these, right? So yeah, so here's we have object properties, right? Objects within objects, or this object property containing a nested array, right? So yeah, we're going to be using this quite a bit throughout the semester, right? And you navigate, to get to each one of these properties using the dot notation. So you can navigate, some property dot an object property dot another object property dot w, and you get to 2222, right? So again, that's very common with any other language, right? Okay, so a couple of changes. Before you would declare var here, I, X, and A. And one of the things that that were introduced in the new language is that you can now declare things within a scope, right? And not have to have it at such a high level scope. You can have it in a much narrower scope. Like for instance, if the variables I and X only mean something within the scope of this for loop, right? You could use, you could declare the I within the for loop, right? And X, right, we can declare inside of the for loop. And then when you fall off the curly bracket of the for loop, these variables are gone, right? Whereas over here, the variables I, X, and A persist, beyond the for loop, right? So this is definitely minimizes the collisions of the same variable names used in different places, right? And it makes it so much easier to write good code. Functions, it saw a major advancement in the syntax and the capabilities. So before ES6, we only had the functions with a keyword function like this, right? Oftentimes we refer to these as the legacy functions. And they were declared and used like you would expect. You would declare a function, the name of the function, parameters, right? And then you can print out or return values, right? In the new syntax, we call them ES6 functions, or also we call them arrow functions because they have these little arrows symbol over here. Instead, you declare a constant, right, here, and then you assign a function data type, right? When you declare that function, you assign it to that constant. So the constant is what gives the function its name, right? But notice that the actual value here is on the right-hand side of this equal sign, right? So this instantiates a function instance, okay? And then it assigns it to the constant here. See that? And then you would invoke it the same way you invoke this one, right? So here you just say add ES5 2 plus 3. Over here, you would use the same way, the same syntax. Add ES6, 5 plus 4, right? Okay, so that's a difference in syntax, right? There is no function keyword, right? And the arrow is what gives it away that this is a function, right? So basically, we have substituted the function keyword with an arrow keyword. Okay. So what's the big deal? Well, one of the biggest changes is that you can be much more concise with these new syntax. So, for instance, if before you wanted to implement add ES5 with the return value of a plus b, now, right, you can still follow the syntax, right, using a comma b arrow return a plus b. So there's syntactically no difference between this version and that version of the function, right? Other than here I'm using the function keyword and here I'm using the arrow keyword. But in this new version of the language, you can be much more concise, right? If the only line, the only execution line in your function is a return, meaning you haven't gone through a whole bunch of loops and if statements and branches and blah, 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 and there's nothing, you only have a return like we have here, then what you can do is you can drop the return keyword, you can drop the curly brackets and the semicolon. Well, actually, no, you use semicolon over here, right? And just only include the computation of whatever the return statements was doing. So, for instance, in this case, is just returning a plus b, right? So notice that I've dropped many keywords here, right? And many characters that I don't need anymore, right? And so it makes it so much more concise. Okay. Now here, it's iffy if you would do one versus the other, but it's much more dramatic when you see this used in a much more a complex algorithm, which we'll see in a minute. So here's all of using that syntax. Right here we have squares. It has return b times b, and here it is b times b. Now also another syntax is that if the parameter list, right, only has one parameter, like here we have b, well then the parentheses are also optional. Okay. Unfortunately, this is considered to be a bad practice, right? Many folks say that this makes it harder to read, that the parentheses actually make it easier to read, right? And understand that this is a parameter. It highlights the b as a parameter in the parameter list of a function, right? It also makes it easier to read that this is a function, right, with parentheses and whatnot, right? So most IDEs are configured to disallow you from typing this, right? So if you do type it, it is syntactically correct. The IDE often will immediately add the parentheses for you, right? Because the default configuration is that it's much more readable, right, if you add the parentheses, right? Other things that were added and improved in the ES6 was the use of keyword this, the keyword this, right? In JavaScript prior to ES6, the keyword this, right, changed meanings as the execution of the program progressed, right? And it made it very hard, right, to do certain things. If you had this keyword only one, always the same value. Typically, in any other programming language like Java or C# or whatnot, the keyword this always references the instance of the object that you're in, right? Well, not in JavaScript. Right? If you use classes in JavaScript and whatnot, right, the keyword this actually is tied to the nearest function scope that you're in, right? So here, if you use the keyword this, here you have an array that you're iterating over, right? And then you're calling a function for each one of the array elements, right? So in here, the keyword this would be tied, right, to the instance of the function that you're inside, right? Which is not what we want, right? The keyword this would be, in any other language, right? The keyword this would be pointing or referencing the higher level object instance always, right? Not here. So a very common workaround, right, in ES5 in the old syntax is that you would store, right, in a local variable the value of the keyword this. You would store it in a local variable so that when you went inside of the loop, right, the function here, it would destroy the original value of this, right? But you would still have a reference to the old value of this, right? Before you went in here and this mocked up the value, right? Today we don't have that problem, right? If you use the arrow function, the new arrow function, the keyword this means the same everywhere, whether you're outside of the function or inside of a nested loop inside of another function. The keyword this always points to the same thing, right? Whatever it was before the function and inside the function, it's always pointing to the whatever instance of a class or object that you're in. Okay, so that's a great forward step with the language. Also, the language provides default parameters. So here we have functions, and you can having a parameter list over here, and so if you want to make certain parameters optional, meaning that you don't have to pass the value, like over here, you can call f here just with one, right, which gets assigned to the parameter x. So you don't have to pass in y and z. The way you can do that is that you can give it a default value. Now you can't pass values here for the values of y and z if you provide them here, right? And it overrides the default. Or if you don't provide them, it still keeps the default value declared here. Okay. All right. Let me close that. Close that. All right. Any questions so far? Okay, so let's talk about destructing. Not destroying. We're not destroying anything, right? So it's a great new syntax introduced in the language. So destructing in the new language again provides a compact way of doing certain things that would be much more verbose in the older syntax, right? So let me show you in the older syntax how you would do certain things with arrays. So let's talk about arrays first. Destructing works for arrays and objects. So let's look at arrays first. So here's using the older syntax, which you would be familiar with. So here we have a list that contains 3 numbers, and you can, if you want to access each one of the items, right, you would use the familiar square bracket syntax, right? We would say list sub 0. Now A has the value 1, and B has list sub 2, so it would have the value 3. Right, so A and B have 1 and 3. Everybody good? Okay. Now, if you want to swap them, you could use a temporary variable where you can set the value of A into temp, right? Then you can store then you can flip B into A, and then B gets temp, right? So you have 3 values that are swapping the values across each other, right? Now, in the new syntax, right, we introduce this new destruct syntax, right? So we still use square brackets on the right-hand side of the equal sign, right, where you construct or you build, right, a data structure from constituent parts, right? So the 1, 2, 3 are parts now of a bigger data structure. So we have constructed, right, a data structure out of its constituent pieces. Well, you can invert that by putting the square brackets on the left side of the equal sign. See that? These square brackets are now on the left side, right? And so what this allows you to do is to destruct. So the square brackets on the right-hand side are constructing the data structure. Well, the array syntax on the left side are destructing, right, the data structure. So the data structure is list, and what these square brackets are doing is that it's extracting the elements, right, of each one of the elements in the array by their position. So here I am extracting A as being the first element, right? So now A, basically you're declaring new variables A and B here, which A gets the value from list, by its position. It is in position 0. That's why it gets the value of 1, because list has 1, 2, 3 in that order. And then notice that there's a comma in there, meaning I don't want to do anything with the second position or position 1. And then I have position 2 over here, right? And so I'm getting the value of list that is in position 2. In this case, it's 3, right? So this would be equivalent to doing this, list sub 0 and list sub 2. Yes, but this is so much more compact, right? There's no need to do indices, right? 0, 2, it's so error prone, right? Of knowing which index do you mean, right? Also, it's a much more compact, right? When you are going to swap values, right? You can just say b comma a is equal to a comma b. So there's no need to declare a separate temporary variable, right, to do the swap, right? They just swap amongst each other. Yes. So anyway, so this is also a syntax that we're going to be using very, very often in JavaScript, right, and throughout all our assignments, exercises, labs, and certainly in the Canvas application that we're building. Now you can do something similar with the object syntax, right? So here we have an example using the older syntax where we declare a JSON object of A, B, C, and D with different values, 1, 2, 3, 2, 3, 4, and so on and so forth, right? And if you want to extract each individual item, right, we can use the dot notation to decompose, right, or have access to each item by their name, dot A, dot B, dot C over here, right? Again, on the right-hand side, the curly bracket syntax is used to declare or construct a data structure, an object data, JSON object data structure. And then using the names of the properties, we can use the dot notation to extract, right, each one of the items into a local variable. Yes? Well, you can do that similarly, just using this syntax, right? Curly bracket on the left constructs the data structure that you have on the right side. So on the right side, we have used the curly bracket to construct this object with A, B, C, and D. And on the left side, we are destructing, we're extracting each one of the elements by their names, right? So this is A and C, A and now these have to match the name of the field of the property, and they get the values of those properties in the object. So A becomes 1, 2, 3, and C becomes 3, 4, 5, right? Now, unlike the array, this is position based, right? So in the array, you have to be in position that the items were constructed, right, in the order, right? So A gets 1 and B comes 3 because A is in the position of the number 1 and B is in the position of the position 3, right? Now the names of the variables are irrelevant, right? This could be the value XYZ, and this is 2, 3, 4. What matters here is the position, right? The names don't matter. Whereas in the object world, right, what matters is the name of the property, right? So this A and C are matched against the properties A and C. So the names are crucial. They have to match, if you're extracting things. Now the position that they are in is irrelevant, right? So this you could say A comma C, or you could have said C comma A, right? The order doesn't matter, the position doesn't matter, but the name matters, as opposed to the array, the position matters, but the name doesn't. Okay, so and we can also use this syntax, right, of destructing. We can use it along with functions, right? In a function, right, you can pass parameters, right, of any data type, numbers, Boolean, strings. You can pass any value. You can also pass an object. So here it is, right here we are passing H with an object that has name and value, right? Name is a string, right, and value has 42, right? And we can extract each item individually. We say object.name, object, .value, right? And then we print it out. Everybody good? Okay, so notice that it is somewhat inconvenient having to always provide arg.name, arg.value, right, to extract each one of the items in the object, right? It would be much more convenient if I didn't have to do that every single time, right, of adding the dot notation. If I could only do this once, right, and then never again. So that's where destructing comes to the rescue, right? You can use also the destruct syntax, right, in the parameter list of the function. So this is expecting an object. This is expecting an object that has property names, name and value. And indeed, I am calling it with an object with name and value. And what the curly bracket does is that it destructs the object that you are passing. I am passing an object whose property is name and value. So this destructs this, and so assigns to the property, to the local constant name and value, the values of the object attributes or properties, right, that they're assigned to, right? So then we have, now we can just we don't have to use the name of the object that it's declared. We can just use the names of the properties themselves, right? Wait, what's the difference here? Oh, yeah, this is just illustrating the fact that the order of the declaration of these properties doesn't matter, right? Because again, we're using the names of the properties, not the position when you're doing object destruction. Now, what if you want to change the name, right? Because the name that you gave it in the object that you're passing, right, maybe it was too verbose, or maybe you want to rename it. Maybe these were too generic, right? And you want to give them a little more useful names. Here, you can rename them by using colon. So colon allows you to rename a property that needs to match. This name needs to match this, and this value needs to match this value. But you can rename them locally, such as N and V. It also works with arrays, although in arrays, the order does matter. So name here and value are getting the values of bar and 42 in that order, right? Because the name is in position 0 and gets the value of the parameter position 0 var, and then val gets the value of 42 in that order. So if I flip it around, it would not work, right? Yeah. Also, introducing in this version is again the overarching goal. One of the overarching goals was to make the language much more compact. So, for instance, if you find yourself that you have an object that we are declaring a property whose value is a variable, right? And here's another property, and the value is it's a variable. Now, if those variables are the same, right, the names of the variable are the same as the name of the properties, then you can use the shorthand of just dropping the property name or the value name, right? You can say just x comma y is the same as x and y colon y, right? Again, this syntax that we're going to be using quite often throughout the semester. So, become familiar with it, okay? Everybody good? All right, so let's talk about arrays. So arrays also saw a big bump in support in the language, providing all sorts of really useful functionality and ways to manipulate and convert, transform, and iterate over arrays. So here's let's go over a few. Certainly there's many more functions that are useful, but let's go through a few of them. Right. So here we're declaring an array that has 10 numbers, 1 through 10. And so the filter function allows you to provide as an argument, you can provide a function that needs to return either true or false, right? And so what filter does is that it iterates over the array, right, one at a time, and it passes each item to the function, right? So it passes 1 to the function, 2 to the function. Notice it's an arrow function. This would work also with a regular function, with a function keyword, right? But more and more, we're going to abandon functions for this case, right? And instead, we're going to prefer the arrow function because it's so much more compact, right? You don't get the verbose function, things like that. You just can say use the arrow instead. So anyway, so filter, like the name says, right? It filters items from the original array. So you give it an array, right? It's going to return a subset of that array, a smaller array, right? That it's only going to keep certain items, only the items for which this function returned true. Right? So this function, if it returns true, then I'm going to keep the item in the original array. Otherwise, I'm going to skip it. Now, we're not modifying the old array, right? So the old array stays the same. We're not touching it. We are computing a brand new array, right? That contains the values as a subset, right, of the original array, right? So for instance, here is an example of calculating the even values of this array, meaning 2, 4, 6, 8, 10, right? So we are returning whether that value 1, 2, 3, 4, if you divide it by 2, right? If you have a modulus, right? Meaning, do you have a remainder, right? So if the remainder is 0, it means that the number was divisible by 2. It doesn't have any remainders, right? And it's an even number, right? So if I pass a 1, 1 divided by 2 does have a remainder, right? It's not 0, so it's false. Right? Is it equal to 0? No, so it's false. So it skips over it. It's not an even number. Then it goes to 2. Yes, it is even. So it goes into the new array, right? 3 doesn't, 4 yes, 5 no, 6 yes, and so on and so forth, right? So in the end, the even is a brand new array, which is the subset of this all array, and it only contains the values 2, 4, 6, 8, and 10, meaning all the even numbers. Here's the same one, but using the compute the odd, right? And it's using a much verbose, compact syntax, right? Notice that has dropped the parentheses, even though my IDE is not going to allow me to do that. Notice that it only has one return, right? So it doesn't have the curly brackets and it doesn't have the return keyword, right? Very, very compact. See that? Very abbreviated, right? If the number is not, right, different than 0, there must be an odd number, right? So odd in the end is going to be a brand new array that is a subset of the larger array, but it's going to contain 1, 3, 5, 7, and 9. Okay. Yeah, note the syntax. Right, so filter okay, yeah, so how would you do this with the old syntax, right? In the old syntax, you would use a function keyword, right? The value, you can drop the name. So this could be an anonymous function. That's fine, even in the old syntax, right? And then you're returning whether 1 is divisible by 2, right? And the remainder there. So notice that, compared to the new syntax here, it's, what is it? It's half as long, the implementation of my filter function, right? It's half as long as using the function keyword. Okay. So yeah, so for most of these cases, I am going to be using the arrow function. Nevertheless, for actually declaring a function, I'm going to keep the old syntax, the function syntax, right? Even though we could use the new syntax, I'm going to use the older syntax. Now, you have to be careful when you use these new syntax of these very compact syntax right here, right? You should only do this if you are certain that this works, right? That this actually computes what you're looking for, right? Because, if it doesn't work, it's hard to debug, right? There's no place to put a breakpoint, right? So you could step through this. So the only way you can step through it is to convert this into a return statement, right? Like this. So for instance, here, we are returning because, right, and instead of using the regular arrow function, we are putting a console, we're putting a return, right? Again, because this allows you to put a breakpoint, right? Now you can put a breakpoint on the console log or the return and see what values are being returned, right? Otherwise, you would not be able to do that. So be careful, right? Putting breakpoints and things like that. Another huge leap forward was the map function, right? That just like the filter function and just like all these array functions, right? They iterate over the original array, right? Now filter returns a subset, right? It creates a brand new array, which is a subset of the original array. Whereas map, what map does is that it calculates a brand new array. They all calculate into a brand new arrays, right? But this one is the same length. It has the same number of items as the original. But the new items in the new array are a function of each of the items in the original array, right? So the first item in the map, it'll be some computation from 1. And then the second one will be some computation from 2, and so on and so forth. So what it does is it takes an argument, a function. Here it is. It's a function that takes arguments as I, meaning I'm iterating over all, and I is getting the values of 1, then 2, then 3, then 4. What am I doing for each one of them? What I'm doing is that I'm multiplying I times I, right? So each one of these is returning the square of each item, right? So this becomes 1 times 1, so square is 1. Then 2 times 2, so this is being added to the array. So square has 1 and 4. 2 plus 2 is 2 times 2 is 4. Then 3 times 3 is 9. Then 4 times 4 is 16. So I am calculating a new array which has all the squares of the original array, right? Very, very useful. We're going to be using that quite a bit. Okay. So here's another one, right? Find index, right? Is very similar to find, but whereas find returns the actual item, right, that it found, right? Find index returns the location where it's found, right? So let's take a look at this, right? So we have find. Find, again, iterates, all these iterate over the original array, 1, 2, 3, 4, 5. And so I'm looking for an item, the first item that makes the predicate true. Right, so find array, iterates over 1, 3, 4, 2, 5, returning whether that item, each one of the items, whether they are larger than 3. So 1 is not, 3 is not, 4 is. So this stops at 4. So what does this return? 4. Because that is the item that caused it to not be true anymore. I'm sorry, that makes it to be true, and then so it stops. So find index works exactly the same way, but it doesn't add value. It returns the location that it is, the index where it was. So if I'm looking for 3 or greater than 3, then 1, position 0, position 1, position 2, I found a 4, right? It's greater than 3, so its position 2 is correct. And then filter here, I only want the values that are bigger than 3, right? So I end up with 4 and 5, right? So filter computes a new array, right, with the values that make the predicate true, okay? String interpolation, right? So string interpolation is, again, another a very powerful feature, right, that allows you to manipulate and work better with strings, right? It introduces a new quotation mark, right? We have the ones that you're more familiar with are either single quotes, double quotes. So this one introduces the backtick as a quote, right? And what it allows you to do is it allows you to embed now in this string expression. It allows you to embed function calls of variables, right? That they need to be able to render or be cast or evaluated as a string or number, right? Something that can be easily converted into a string, right? So here we are embedding, right, in this hello, blah, 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 right? and we're using the object customer.name. In this case, is customer name Alice. So this notice it has a curly bracket around it and the $sign in front of it, right? So this evaluates Alice. So hello, Alice wants to buy, and this is the card amount. So amount to 7. So want to buy 7 card product. So bar. So buy 7 card bar for a total of, and then amount would be 7 times unit price 42. So 7 times 42 bucks, right? And print.com, right? So again, this is a string that we have dynamically calculated and we have concatenated together without using the pluses, right? An alternative to do this, right, is that you would use a quote, hello, close quote, plus, and then customer.name plus, right, comma, quote, want to buy, close quote, plus, right, card or concatenation. Now that is very error prone, using the plus sign and whatnot, right? In this context, that is string concatenation, but in other contexts, it would be, number arithmetic, right? So to dispel any of those problems, right, this one has only one interpretation, right, is that we are building a string by concatenating them using this new syntax, okay? All right, yeah, so let's talk about modules now, right? So again, also in ES6, they introduced a feature called modules, right, that addresses one of the biggest gaps in the language, in JavaScript language, was that before there was just a single namespace, right? So whenever you declared a variable or a function, a data structure, right, everything was declared in the same namespace, right? Which limits quite a bit what you can do. Let's see, is there a question on the chat? Right, yeah. So by having just one single namespace, right, you have the problem that if you declare one variable, early on in your code, right, and then later on you use the same exact name for that variable, right, you are overriding or you're changing the value of that variable, either intentionally or not, right? Or if you declare a function, early on in your code, and then you load another library, another JavaScript script, right, a file, and it has the same name for that function, right, it just overrides whatever initial declaration you had, right? So there was no way to manage the fact that certain things had different scopes or different namespace. So with the introduction of modules, this fixed this huge problem. Now, if you declare variables or functions, they only were available within that one file, right? Unless you exported them, right? You can export so that other files could look into other files, right? And import anything that other files might be exporting, right? So everything is at file scope, right? And then only things that are exported or imported can then share amongst each other, right? So this was huge, right? So let's take a look at some examples. So here we have a couple of functions, variables, constants, right, that are being exported. So for instance, this might be math.js, right, where I'm declaring a function called sum, right, that returns the x plus y, right? And notice that this is being exported. Now, if this were not exported, right, then this function would not be available outside of math.js. Only things that are exported can be accessed from outside, right, by explicitly importing those functions or those variables, right? And so you could import the whole thing by saying import star as math, right, with and then the name of the file, right? And then you can give it a name locally, like some app.js can import, give it a name, right? And then you can use the dot notation, right, to access each one of the items within that library, that file, okay? And so math becomes basically an object an object that contains all the functions and variables that are exported by that other file. Okay. You can also use destructs, the destruct syntax, where you have this curly bracket, which basically is that, just like math is an object that that includes all the items that are exported in the library. Well, that object, right, instead of having to declare a new object name here, right, I can just destruct what is being imported from the other library, and I can destruct it right away and assign locally, right, these constants, which are going to have the values or references to whatever is being exported in the other file, right? And they have to match by name, right? So sum and pi have to match the variables and functions that are declared in the library or file that is being imported. Make sense, right? And so here's another, here we are exporting everything, export everything from libmath. And here we have a variable being declared as the E constant, right? And but here's an example of declaring a default function, right? You can use the default keyword, right, to declare just one item, right, either a function or a variable as the default export, right? And then the default export from the import, you don't have to use the destruct. You don't have to use the destruct operator, right, to extract each one of the items. Instead, you can just use it like that, right, without the curly bracket. So you could say import, and X would be tied to the single thing that is exported by default from the other library, right? Classes, we're not going to be using classes, but real quick, right, you have the class keyword, right, where you can declare methods inside. One of the methods can have a special name called constructor, which is a constructor, right, which creates the instance of object instance of this class, which you can have parameters that initialize the properties. And the way you declare properties is by using the this keyword, right, where you can declare properties like ID. You can call local functions, right, and to initialize values. So, for instance, you can initialize other properties such as the X and the Y if you provide in the constructor. You can extend, right? You can have inheritance, where here you have a rectangle extending the shape class, right? Where you might take in the constructor other properties, right, that make sense for a rectangle, like width and height, and the more abstract properties such as ID, X, and Y can be used to instantiate or initialize properties that have been inherited from the shape, from the super class, right? So you can call super, and it must be the first line in the constructor, and you can initialize the properties for that super constructor, right? Plus, then you can initialize properties that are specific to this particular class, right? Then you can provide setters and getters that allow you to manipulate local properties like width and height, right? And that allow you to set or read properties of the instance. And then you can use the dot notation, dot area, which even though it looks like using the dot notation, and they're not like functions, right? Like these gets, right, where they have parentheses, they're actually using those these functions, right? Even though it looks like this is just a property, it's actually a function. This is saying is reading the value of area, so it's doing a get and then comparing against 1,000. So you can use like a regular dot notation. You can also declare static functions inside of a class. which allow you to have the same instance, the same implementation for multiple instances, right? So that it's not overloaded or whatnot, right? That you can um, use properties that are static, like for instance, counting how many instances have been created, so that it doesn't change per instance, right? It's declared for the class, not for the object instance, right? You can override certain functions that are inherited from the base object class, right? That, for instance, all classes inherit functions such as toString, right? That give you a string representation of the object. You can override it, right? So that when you call toString, right, it calls your instance instead of the one you inherit from the base object. Okay. So the assignment this week is geared towards giving us an opportunity to practice some of these features, learn about the language, get a chance to become familiar with it, with first practicing some really simple things like just declaring certain variables, getting familiar with the different data types, creating some JSON objects, working with arrays, and all the various functions that are available for arrays, like maps and filters and find and whatnot, right? Also working with objects and introducing things such as the destruct operator, and another operation that we haven't looked at is the spread operator, right? So anyway, so this will give us a chance to practice some of these features, and then once you had a chance to become familiar and you're more confident with using the language, you'll be asked to revisit the implementation of our Canvas application, right, and add JavaScript to that website that we're building. Okay. So here's the lab. It just rewinds and just revisits the fact that we have been using JavaScript all along, right? And that we are building what we call a single page application, or an SPA, right? And what we mean by that is that we're not implementing regular HTML documents where you navigate from one screen to the other, and so instead we're using our own navigation mechanism where we are only ever using this index HTML document that has a single div, right, that has the root ID, and we are rendering everything into that div programmatically using JavaScript, right? So the navigation has to happen, everything inside this one single HTML document. Before single page applications, you would have different HTML documents with hyperlinks pointing to each other, and you can navigate from one to the other. Here, the navigation has to happen all within the same HTML document. And the way we do that is by using routes, right? So we're still gonna be using that mechanism, but I wanted to point out that applications that use this strategy of implementing navigation, without actually going to other screens, right, all within the same single HTML document, are referred to as single page applications. And React.js is one of the more popular libraries for implementing single page applications. Okay. All right. So let's learn about JavaScript. First, we'll learn about some of the simpler things, such as some really basic things, such as declaring data types and things like that. And so let's have a lab 3 screen, right, where we can practice all these new features, right? So let's take a look at what we have so far. Okay, so here we have the application that we've been playing around for the last couple of weeks. We have lab 1, lab 2, right? Lab 2 lab one, we learned about just learning about HTML. Lab two, we learned how to style things in the to make it look a little more pretty. And then lab three, we haven't really done anything. Okay, so let's create a lab three as suggested here in lab three index. So let's create a file in labs three. Did I copy it? I thought I copied it. Copy. There we go. And in there, let's paste lab three with an ID there. Please, I've been adding IDs to all the code snippets that I am sharing with you. Please honor those IDs, right? Because we're building automated tests to confirm that everything is working, that you've completed everything. And if you don't provide those IDs, that would probably none of our tests are going to work. So please include those in there. So also we're going to add lab three to the routes so that we can navigate to the labs. So we had here our labs, and here we have routes for lab three. And let's import our lab three. Oops. Let's import it. There it is. And I'm actually going to add a star in there because I'm going to have a couple exercises practicing how to use routes. We've already been using routes. I mean, there it is. There is a route, right? But we're going to discuss a few advanced topics on using routes, and we're going to need the star for that. Okay, meaning I'm going to have another route in here, right, inside of lab three. Just to discuss. In particular, we're going to discuss how do we navigate from one screen to the other, but pass parameters, right? When you navigate from one screen and you pass parameters to the other screen, right? So we're going to practice that today. So yeah, here's lab three. Probably we want to add some container, all around, a little bit of margins all around. And okay, so let's see. Yeah, so let's first learn about variables and constants, something trivial. And I'm asking you to do all these exercises, each one in its own component, right? In the previous assignment, I might have not asked you to do that. We did do it. I illustrated how to do it, although I wasn't requiring you to do. But here, I will be asking you to please, each one of these exercises be declared in a separate file, right? So let's do that. So in lab three, let's create a component that illustrates how to work with variables, constants, and whatnot, right? So here we have so we have three types of variables. The legacy var, all right, which we're not going to use ever again. This is the first and last time you will see this being used in this course. Instead, we're going to stick to let and const, right? And so const, as you might imagine, right? These are not variables, right? Identifiers, right? That are holding values, right? That are only initialized and when you declare the constants, right? And then you can't change them after that. Whereas let allows you to declare a variable that is meant to change over time. Okay, so there's our regular return, and here we have you might have seen this in earlier assignments, but these the curly bracket syntax allows you to escape, right, the HTML syntax, right, and go back to the JavaScript syntax, right? In that, right, so here you had JavaScript syntax, then this return is returning HTML syntax, but then within the HTML syntax, just like I can embed HTML within JavaScript, well, curly bracket allows me to embed JavaScript inside, within HTML. So I can go back and forth from JavaScript down into HTML, and then from HTML back into JavaScript, and then back to JavaScript, right? HTML and JavaScript, right? So what this is allowing you to do is declare that I want to render here, not hard-coded text or numbers, whatever the value for this is. So here's a function scope var, right? So whatever value it is, so this renders as 2 and so on and so forth, right? So let's go back to our lab 3 and import that. So variables and constants, right? And then it renders right here. So let's make this a little bigger. There it is. We have variables and constants 2, 5, and -3. So this is 2, right? This is 5, right? And then subtracting 1 from the other gives -3. Okay. So yeah, so this is just for you to practice, some lowballing it here, right? Some really simple things. Maybe I should perhaps add this class to the lab 3 here so that it looks a little better for you. Again, it's not required, but I think it makes it look much prettier. Okay. All right. All right, so let's keep going. So now there are different variable data types, and let's explore that. And so let's create a component where we can play around with different variable data types, right? So we have numbers, dates, right? Strings, booleans, right? So let's take a look at some of these. Here's a number. Notice that we're not declaring them as number. I mean, we could say that the type for this is number, right? Because it is TypeScript. Although here is not necessary, right? It is the data type is implied by the value that we are assigning, right? Again, this is of type strings. Again, since this is TypeScript, we can explicitly declare the variable to be a specific type, right? And then we have this as a Boolean, right? This is Boolean, right? And true or false. And then is number string. So here you can use the type of operator that can be applied to a variable, and it returns the type, right, as a string, right? So type of the type of this, it'll return a string saying that is of type number. So this is a string. So these are strings. These are all strings. Okay, and then we're printing out, right, the number variable, right, which is 1, 2, 3, and this is the floating point value. It's also a number, right? And so let's bring that in here. So this is variable types, right? And then there it is, right? So actually, also I didn't add it to each one of these, but I think each one of these should be a HR, a horizontal ruler, right? So that it makes it easier to read with these rows. Okay, yeah. So please add those. It'll make it easier to read for the TAs. Yeah. So let's take a look at another one. We have Boolean variables. So let's introduce those. So this one I didn't give you the whole function, right? You can see I only gave you a snippet. So some of my exercises, don't handhold you all the way through. They just say what the expectations are, and then you just make sure that it renders as displayed here, right? So for instance, I'm giving you the name of the function of the file, and you can derive what the name of the function is. You should be able to know that this is TSX. Well, then you probably have a default export function. Oh, export function Boolean variables, and I'm just going to paste in the content of that file, of that example. So I'm going to just paste it in there. There we go. Oops. Backwards. There we go. So yeah. And the last one will be horizontal rule. So let me import that into lab 3. So it will be Boolean variables, right? And there we go. Okay. So notice that in Boolean variables, we are declaring several variables of type, well, actually, yeah, we declare a couple of numbers, floating point, right? A couple of true, false variables of type Boolean, right? And then here I'm demonstrating using various Boolean operators such as the AND operator, the OR operator, right? The NOT operator. So these all should be familiar to you from other languages, right? And they behave the same way. So those are definitely the same. Now, this one's a little slightly different. So here's we have the triple equal, right? So the triple equal it addresses a big problem with the double equal, right? Before it was very common to use the double equal, and here I am telling you not to ever use the double equal, and it's because the double equal will try to cast the values at each side, right, or the parameters on either side, and then do the comparison, right? So that if you could cast a character 1 to a number 1, then you can compare a character with a 1, right, with a number. And oftentimes you don't want to do that, right? That might be a source of bugs, right? That it allows you to do that. So this one's much more stricter, right? So this one, first it checks to see the data types on whether they are of the same type, right? That they're both number on either side, that they're both Boolean on either side, or strings, or object instances, or whatever, right? Once they are as determined that the same of the same type, then it goes in and it compares the value. So definitely stick to the triple equal, right? Also, same thing with the not equal, right? Is not and then equal equal, okay? Then you have the various range operators, whether it's less than, greater than, or less or equal, or greater than or equal. Those are all, again, supported just like any other language. Then here, one point that I'm making here is when we render them on the screen, typically for true, you might want to just render the variable true, right? Or true one, true. That's the name of the variable, true one. So I might have said, well, just render it like that, like any other variable, like that, right? But check out what actually renders, right? If I would have done that, if I save that, notice that it doesn't render anything. See that? Even though true one has the value of true. So by default, React.js will not render Boolean values, right? And that's by design, right? That's actually going to come in very, very handy later on, right? If you want, so that we can use Boolean variables, right, as a mechanism for hiding or showing content, right? That, if you and or not or whatnot, Boolean variables with content, right? It'll either render the content or not render the content, but you don't want to append in front of it or append afterwards, the actual variable value, true or false, right? So that's actually done by design, right? If you truly want to display the value, in this case, you have to add the plus and then just convert it into a string representation or use the toString operator, okay? So anyway, so all of them are using the same strategy of concatenating an empty string to convert the whole thing into a string that can be rendered on the screen like that. All right. Yeah, let's keep going. Okay, so conditionals. Yeah, so here's an example of using what I was telling you about, right? The if-else, where you might show content or not show content, right? Based on some Boolean operation, right? So let's take a look at that. So a new file, if-else, let's create that. So a new file, if-else.tsx, and then here we're going to export default function, and in here, let's see what we got. Let's copy that and let's paste this in here. No, like that. Okay, so let's read through this. So here we have two variables, two booleans, right? True one and false one, right? And so one is true, the other is false. And then in here we have a heading, and here we have a true one, which is true, ended with HTML. See that? So what this is basically doing is saying, okay, so this whole thing evaluates to, right, the results of ANDing a Boolean operator with content. Right? And as I mentioned earlier, right, true one is not going to render. Here, what's going to render is only the right-hand side. Right? And the right-hand side would only render if the left-hand side of the AND operator is true. See that? So if this is true, the whole thing evaluates to just paragraph. How about this one? Using a different approach, right, is using what is called the ternary operator with the question mark here. See that? It's an expression that says, if the left-hand side evaluates to true, then I will, this whole thing will evaluate as my first parameter here. See that? Otherwise, if this expression evaluates to false, then the whole thing evaluates to what you have here on the right-hand side. See that? So what do you think? Let's see, if this is true, it should show true one. What about this one? False one, so not false, so this is true. That means that it renders not false. Right, so it should render true one and not false one. It should not render that. Right, so let's import it. Let's see, into our lab 3, if else. So we'll call, we have if else, there we go. So if else renders true one and not false one. Yep, so what we were expecting. Everybody good? All right. All right, so let's revisit that ternary, right? And we could, for instance, what we could use it for is for when you're logging in, right? If you're logged in, I'll welcome you. If you're not logged in, I'll ask you to please log in, right? So let's take a look at that example, right? So this will be, we'll create it in here. New file, ternary operator, and we'll create a function here. So export default function ternary, and we're going to copy paste the content in there. We're not going to have that. And let's close that up. So again, based on this variable, right, if it's true, then that you are logged in, I'm going to welcome you. Otherwise, if it's false, then I'm going to ask you to please log in, right? So again, this is a small little example of where you might use this, right? So let's import this into our lab 3. This is our ternary operator, right? And it's right there, logged in. So you are logged in and you are welcome. Yes, you are logged in, right? And you are welcome, all right? Okay. All right, so here are a couple of other examples, right? A little more involved. Let's see, let's conditional output if else. So let's see, let's take a look at this example. This is an export default, and let's copy the content. Let's talk about it. Oh, I don't need this. Oh, copy the whole thing. No, I don't need that. There we go. Oh, okay. I copied the whole content. I didn't need to. All right. So first of all, note that. Oh, okay. Yeah. Okay. So let me actually use the content in here as is. So it'll give us something to talk about. So first of all, notice my declaration of the function here, right? Notice that I'm not using the older legacy function keyword, right? You don't see that here. Instead, the functional component is being implemented using an arrow function instead. And yes, you could use either syntax, right, to create the component, either the older legacy syntax function or this newer arrow, right? So a few differences, right? One of the main differences is that you cannot use the export default directly on the declaration of the constant. That's one difference. You have to then export it by default later, right? After declaring the function, at the bottom, right, then say, okay, well, this is actually the default export, right? And this only means that when you import it, right, you can import it by the name of the default, right? You don't need to use the curly brackets to do the imports, right? Which we haven't seen examples of that, right? We saw that in the slides, but we'll come back to see some of those a little later. So notice what's happening here. Notice that here you have logged in, right? And if it's logged in, this whole function, right, returns blah 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 blah. Welcome if else. Otherwise, right, it's going to return this. Notice that we don't have a single return down here, right? Like we've done in other places, right? Actually, we can have another return here, which is going to return just null, which means that I can't because I have the if else. If I ever get to that line, right, whoever called me, it's not going to render anything, right? It won't render it, and it's a legitimate, right? It is a legitimate return, right? That you literally return null because I don't want to render anything, right? But I'll never get to that line. So here I either return one or the other, okay? And so this function, right, this component, when I use it, it'll render either one or the other. So this is a much more verbose version of using the ternary syntax, right? That I do the predicate, which is the logged in, right, question mark, and then I either have the first heading version or the second heading version divided by a colon. This is a much more verbose version of doing the same thing. Now, the reason you would do this version is that it might take you, this output might be much more complex, not just one heading. It could be an entire maybe loop, right, or have a whole bunch of other branches, right? And so it might be a complex algorithm to compute what you want to return, right? Which you would not be able to do maybe in a, or might be harder to do in a ternary. Okay. In both cases, let's import this here. So this is conditional output if else, right? And there it is. Welcome if else, right? Because it's true, it renders as this. Now, if this is false, notice it would render the please log in if else. Excuse me. Right. So true renders this output. Okay. And so the other way of doing it is inline, right? Doing the same thing, right? So let's re-implement this, but using inline. So let's paste that. So let's review this. So here we have the div, right? We have the variable logged in false, and then I have two versions that only one of them will render, right? Because they're both driven by the same Boolean variable that can only be true or false, right? And the AND operator is using the two versions of one of them where it might be true, where the other one is the inverse of whatever the other one was, right? So in these two AND statements, only one of them will render, right? If this is true, it will render welcome. And if it's false, it will render the second one, right? But this is an alternative way of doing the same thing as previous, right? As having explicit returns, right? Here you have one return, but you have the logic embedded in the HTML, right? As opposed to the other implementation, you have the HTML embedded in the logic, right? Again, this implementation is you have HTML is embedded in the inner JavaScript that is surrounding it, whereas this one, right, you have a logic that is embedded in an outer shell that is the HTML. So this is the HTML is surrounding, right, the logic, right, that is implemented with JavaScript. Okay. All right, excellent. So let's take a look at more. All right, so let's talk about functions. So functions, again, we mentioned that there were two versions, right? The kind of like the legacy, the old way of doing things, which again, they're still legitimate. They still work just fine. As long as you stay away from this keyword, you're fine, right? Because this keyword behaves weird in the legacy functions. But other than that, right, they're pretty useful, right? So let's take a look at first at the legacy functions. So let's create a component for legacy function, that, and let's copy and let's talk about it. So here we have the default function, legacy function, which is being exported. And then we're declaring another function up here. Notice that it's not being exported, right? So nobody could possibly ever use that function outside of this file, right? That function only ever exists in this file. Nobody can see it unless I export it. Then somebody could import it, okay? So here's legacy function, and we are invoking the local function with add with two numbers. Those two parameters, we are declaring the data types for each one of them. And then we are displaying the values of each one here using the legacy version of this. And then 2 plus 4, right, and whatnot, right? So it behaves as you would expect, right? So here we are displaying the value of calling the functions add 2 plus 4, right? So let's include that. The legacy functions here. Legacy functions. So there it is, right? We're calling it 2 plus 4 is 6, is what you would expect. Now, it only becomes interesting when you contrast it with for the arrow functions, right? Now, so the arrow functions is the same implementation, right? But the syntax is that here we are using to implement subtract, we're using the new syntax, the new arrow syntax, right? We don't have the function keyword, right? Instead, we have a constant that is being assigned a function instance, right? That is implemented using the arrow keyword over here. And you can use it like any other regular function, right? The invocation of the arrow functions is the same as the invocation of a regular function, legacy function, right? So let's import the arrow function into our lab 3, just to confirm that it works just the same. There it is. So new arrow function, 3 minus 1 is 2. Okay. Right. So then we discussed that that in the new arrow function, we get a few things for free, right? And a couple of things that were improved. And one of them is that you have an implied return, right? Where, for instance, here you have the multiply function. There's the multiply function. And you could certainly have a return, a regular return like that. So this would be the old syntax, right? And this would work fine. You call the what are you implied return cannot be compiled. Why? Huh? What don't you like? Multiply, const, default. Huh? Isoma because it is considered a global script file. Add import, export, export. I did. Let me import it from here. Implied return. Implied return. Okay. I don't know what I typed. Anyway, it behaves as you would expect, right? But now you have the alternative because the only return here is that single line, right? We can be much more terse, right? We can just remove that, remove the return, remove the curly bracket, right? And just be maybe just in a single line, you could do this, right? And it works just the same way, right? Now, in the older syntax, you could put a breakpoint, right? You could put a breakpoint. There's a line for you to put a breakpoint and everything. Now, when you remove, right, when you remove the curly brackets and the return, there is no breakpoint, right? So these are, you can't debug these, right? So ideally, you would maybe first implement it using the regular syntax, right? You debug it, make sure it works, right? And then maybe you can remove the return, right, to make it much more compact, right? Right, template literals, right? We played around with those. I'll let you play with them on your own. All right, so let's talk about data structures. All right, so let's talk about so data structure is just basically grabbing several data types, variables, constants, right? And typically they would be implemented as individual variables, right? But now you can combine them, different variables, different values into larger, more complex structures, right? Which we call data structures, right? And there are two basic types of data structures. And you have arrays and objects. Now, those objects could be implemented as either a literal object, JSON object, or it can be implemented as a class, right? That has its own setters and getters and property values, right? So let's talk about arrays and objects, right? So first, let's discuss simple arrays. Right, so let's declare a few things here. Let's see, and the simple arrays example, and let's display that. And here, again, we few variables, constants and whatnot, right? A couple of number arrays. So this array contains numbers. This array contains strings. Ooh, look at this. This one contains HTML elements. That's pretty cool, right? And then you can combine them, right? So you can combine a variable that has mixed content, right? It has numbers here, right? With vars and let. It's this one has a constant. This has an array within an array, right? And this is a string array instead of a bigger array. So JavaScript doesn't mind you mixing and matching, right? Different values inside an array, right? It's very heterogeneous. And so, and then let's render it. Let's implement them, right? Let's render, see what it looks like. And so in lab 3, we are going to import, let's see, simple arrays down here. So this will be simple arrays like that. Let's see how that renders. So there it is. So notice simple arrays, this variable where we are displaying the number array, there it is, 1, 2, 3, 4, 5. This one, see that, which is this one, 1, 2, 3, 4, 5. Notice that this displays differently than the default bare bones JavaScript, the way it would display the arrays. In the bare bones JavaScript implementation of displaying an array, it would include the square brackets, the commas, right? Not just the numbers, not just the content, right? So it might seem like a step back, but actually it's a feature, right? It's a great feature, right? Which will become apparent in a second. Right? So same thing with string 1 and string 2. When we display it here, notice that it just displays the content with no commas, right? No commas. What about this variable array? This variable array, notice that it has the value 2. This value 2, which is this one. The value 5, right here. Right? Then constant, which is -3. This here is -3. There it is, right? Then it displays the number array, which is containing there. There's 1, 2, 3, 4, 5. There it is, right? Plus then the string array, which is these strings, and there it is. So notice that it's just a jumbled, contiguous concatenation of all the text values of each one of the constituent pieces of the array. No commas, no square brackets, which is a good thing, right? That's actually a feature. What this allows me to do is the following. Notice here I have an array that contains HTML as its elements, right? And notice that I can just bring in that array and render it and surround it with OLs. See that? So now this becomes what? It becomes a proper ordered list, right? With those 2 line items in there, right? Buy milk and feed the pets, right? Luckily, right, there are no square brackets, there are no commas, right? And I can just literally have the content L1 and L2, right? Oh, those sorry, those two LIs, right? Those two LIs literally added to the DOM, right, without the encumbrance of square brackets and commas, right? And they're not that otherwise I would need to strip them out, right, to so that they would not render because these are OLs, right? I don't want the commas and the square brackets. So actually, it's a good feature that it's going to be used quite a bit in our development. You have array lengths, right? You can display the array lengths. I'll let you do that. So adding and removing, so you can add and remove and mutate the arrays by pushing or slicing the elements from an array. And so let me demonstrate that. And let's talk about this example. And let's import it. So adding and removing in lab 3. So let's do adding and removing. There we go. So in this example, I have 1, 2, 3, 4, 5, right? The same ones that I had earlier, right? String 1, string 2, blah, blah, blah. So this one is pushing, right, to the number array. This allows you to add at the end of the array, right? And pop allows you to remove from the beginning of the array, which I don't have a so push allows you to add, right? Pop allows you to remove from the array. And so when this renders, right, notice that it has that extra 6 here at the end of the array. So same thing with string array, right? We are pushing a new string to the 2, and then when it gets printed, notice that it only renders string 1 and 3. So string 2 somehow was maybe removed. Yeah, actually we are, right? We are splicing out from the string array at position 1. I'm splicing out one element. So I'm removing one element from there. So basically string 2, right? So which is position 1. So this position 0, 1. I'm removing that. That's why in the end you see string 1 and string 3. So same thing probably from the number. Notice that number 3 is missing, right? And that's because splice is removing from position 2, which is 3, right? One element. And you don't remove more than one element, but by default, usually we just want remove. Right? And then same thing, right? Notice that I pushed to the to-do array. This one contained 2 to-do items. I added, walk the dogs, right? So when I render it, I have 3 items, right? That I can that I'm rendering on my to-do list. Yes, it's pretty cool. Loops, I can iterate over the loops. Here I'm just showing you that you can copy from one array to the other. I'll let you do that. So let's take a look at the map function. The map function is one of the most useful functions we'll be using throughout the semester, right? Certainly it can work outside of the context of web development and whatnot, but especially within web development and how we're going to be using in React.js is going to be astounding how useful this is, right? So let's take a look at the map function example here. So let's create the exercise map function and let me illustrate. So let's go through that and let me import it in my lab 3. So this is a map function, right? And so let's take a look at it, the implementation. So here we have a couple arrays. So we have an array of 6 items. We have a square, right, that presumably we're going to be using it to compute the square of this array, probably. That it's just a function that takes a number as an argument, and then it returns the multiplication with itself. Basically implementing the square. Then you have an array with 2 to-dos. Now here, the other implementation that we had earlier were using line items, whereas this one is just plain old strings, right? Because I want to illustrate the use of map in a minute. Okay, so I calculate here using map to compute a new array that has the old arrays, right? So this becomes 1 square, 2 square, 3, 4, 5 square, so forth, right? And then whereas cubes, right, I'm using the same array, a mapping, but instead of passing a function which is implemented outside, notice that I am embedding the function, as a lambda function. It doesn't even have a name. right, inside of the map, right? This is very common in JavaScript that we use functions like lambda functions that have no name, they're anonymous, right? Especially if these are functions that we're never ever going to use anywhere else but here, right? So these are kind of like throwaway functions, right? There's no need to even give them a name, right? And so it's a very common syntax. You'll see it quite often. So anyway, so here we're rendering each one of the squares and the cubes and whatnot, right? And which is what you would expect, right? So 1 square, 2 squared, 3 square, 4 square, and so on and so forth. And then here we have the cubes: 1 cube, 2 cube, 3 cube, 4 cube, and whatnot, right? So it's what you'd expect. Again, no square brackets, no commas, perfect, right? So here's the use of the map, right, to iterate over an array. But as I am iterating, remember, map calculates a new array from an input array. So the input array here is this array of strings, right? Buy milk and feed pets, right? So as I am iterating over the array, I'm going to compute a new array. And what is the array? What is that? The content of that new array? Well, it's going to contain, it's going to contain a line item with the first to do, right? So the to do is the first to do. So this is buy milk. So li buy milk, right? In the next iteration, to do is feed the pets. So this would be li feed the pets, right? So this evaluates to what? It evaluates to a brand new array whose the two new items in that brand new array is the line item buy milk, line item feed the pets, right? Which renders, if it's rendered inside of an OL, it renders like an ordered list, right, with those two line items. See that? So this technique, right, this strategy, we're going to use that very, very often, right, within our own implementation, right, of creating dynamic content as we convert data structures, right, into a graphic representation. Because, I mean, that's basically what we've been doing, right? All these components, basically what they do is that they compute a user interface based off of some algorithm and some data, right? That's all React.js is. It's one big function, right? Or collection of functions that its only job is to convert data, right, and data structures and user input, right, into a user representation. So here's my data and my algorithm, and the output, right, is what the user sees. And so the function converts data structures, user interactions into an equivalent user interface. That's all React.js is. Okay. All right, let's keep going. The find, you do that filter JSON. So JSON stringify is it's a very useful feature of the JSON support for the browser. The browser provides a global object called JSON, right, that allows you to manipulate data structures, right? So let me illustrate. Now, these data structures can be array data structures or could be JSON data structures, right? In our case, we've only seen arrays, right? So let me illustrate JSON stringify with an array, right? So let me copy this. Right? So let's create here JSON stringify, right? And let me copy the code, right? And so notice that here we have just a regular array, right? Presumably these are the squares, right? And here we are rendering the squares using JSON stringify. And what this is doing is that it's taking a data structure, converting it into its string representation, right? And as you'll notice, right, the string representation, right, is this. This is the code, how it would be rendered in code, right? So let's look at including all the commas and square brackets and everything, right? So let me include this, import this. So this is JSON stringify, and there it is. Notice that we get back, right, the original array, including the square brackets, the commas, and whatnot, right? Again, because this is we want the string representation of structure as opposed to, right, the way React.js would interpret it, right? React.js doesn't interpret as a string; it interprets as a concatenation of characters without the commas, without the square brackets, right? Whereas the string representation does include all those additional characters. Where this is most useful is certainly in arrays, right? But it's most useful when you're working with complex JSON data types, right? Of object data types, right? So let's introduce that. Let's talk about the JSON object, JavaScript object notation, which is abbreviated as JSON, right? And allows you to declare, right, objects within a literal syntax that uses curly brackets, right? So let's create this house data structure. Let's see, house, there it is. And let me copy that. And let's talk about this. So, okay, so here I'm declaring a constant house, right, which opens up the curly bracket. So this is a literal JSON instance, right? So it wasn't created with a class or anything like that, right? And it has a few properties: bedrooms 4, bathrooms 2.5 bathrooms, square feet 2,000 square feet, and then it has a nested object. So it's an object that contains another object, right? That has the address property, which contains a whole bunch of strings in there, right? And then you have owners. You have an array of strings. So the object itself can contain an eclectic mixture of data types, some numbers, some booleans, arrays, other objects, right? And the combination from here and there, right? Now in the user interface, right, we are using that data structure and representing, displaying each one of the values. But in particular, I want to illustrate this new JSON stringify, right? So let me bring that into lab 3. So this is house. There it is. So let's take a look at it. There it is. See that? This is what I wanted to point out, right? The JSON representation, right, is the whole string representation, including all the tabs, new lines, spaces, right? Even the quotations are there. Notice that I didn't have the quotations here, right? But actually, the proper, right, official representation of the JSON syntax is that the properties should be quoted, right? Now, when I save this, right, my IDE removes it, right? Because from the IDE's point of view, it is implied. It knows that this needs to be quoted, right? So it'll quote it for you. Now, when the names of the properties are when the name of the properties are just characters, right? And no special, when you don't have any special characters, yes, the browser will be smart enough to not have to quote it. But what if you use special characters? So underscore is fine. Underscore is not a special character. And then this would have to be like that. Okay, bedrooms like that. But what if I use a special character, maybe a dash? So a dash is not a valid character for the name of a property. Notice that it's complaining about it. But if you put it in quotes, right, then it becomes an okay property name, right? And the IDE leaves it alone. It says, oh yeah, no, that's a weird name. You do need the quotations there. Otherwise, right, that character would not work. So same thing here, right? Notice that I don't have bedrooms anymore. And so the dot notation here would have to do what? So bedroom dash room, so that won't work, right? So that's syntactically correct. So would it be quotations here? right? So that wouldn't work either, right? So the React.js has a alternative syntax when you use special names or whatnot for the keys for the properties, right? You can use the alternate square brackets, right, as an equivalent, right? Now this is TypeScript, and TypeScript is not going to like that, and it's complaining that it's not letting me. So in regular JavaScript, it would be fine, right? Let me see if my IDE lets me compile this. Okay, yeah, it accepted it. So yeah, so notice that I can use the alternate syntax where you have square brackets instead of the dot notation, right? Now, typically you would always use the dot notation when you're navigating through properties of an object, but square bracket notation is very, very powerful, right? What this is saying, right, is that now this string could be dynamic. It could be it could be anything. It could be something that I can compute on the fly, right? Whereas this syntax have to use literally property. This can't be a variable. This cannot be a variable, right? It has to be the name of the property. Whereas a string, this could be calculated on the fly. So I could have another variable, right? Const bd bd that has bedroom. Sorry, no, bedrooms. There we go. Right, so notice that because this is a variable, or this is let, right? This could be a function, right? Implicit has any because type string can't. Yeah, it's complaining. It's complaining that because it's TypeScript, right? That hey, wait a minute, what do you mean you're going to be changing this on the fly, right? Because this is already has the particular properties, right? This could be very error prone, right? That if I can on the fly compute this, and then on the fly use it as an index, right? You can make a mistake and then try to access a property that's not there, right? So TypeScript is asking me to add additional code to validate whether things are there or not, which I'm not going to do. But the point is that this opens up a very broad, powerful tool, right, that allows you to work with dynamic data structures on the fly. Okay. All right. So now that we have these data structures, here we give you a little sample of a tiny little app, right, that deals with to-dos, right? So let's create here a little to-do app, a tiny to-do app inside the to-dos directory, and in here let's copy this. So one of the things that here I'm showing you is a function. Here's a function, right? That is creating a little component of a to-do item. So I'm going to render several to-dos, right? And each to-do is going to be rendered as a line item, right? So instead of having the line item, right, embedded in a larger object, I'm going to have it as a separate component, right? And I'm going to pass it as argument, which we haven't seen, pass it objects, right? And I can declare initial values for that object, and I'm using a destruct, right? The function destruct, right, that we saw earlier in the slides, right? So I am going to pass a to-do as an attribute object, right? Which here I'm going to render as the title of the to-do object that I'm going to pass in, the status, which is completed or not, right? And then I'm going to use the value of whether it's done or not, right? Whether the the to-do has been completed or not, as a to create a checkbox, right, and turn it on, right? Again, this is a small sneak preview of where we're going. So let me show you. Here's a list of to-dos that I have. So let's create a little JSON object in here, and I'm going to fill it with these elements of buy milk, the status is canceled, and progress or deferred, and then the done is true or false. Okay. And then we're going to create a little to-do list component, which is just going to iterate over each one of these, right? And it's going to render each line item by passing each object to the to-do item component, right? So let's place it there. Okay, so what this is doing is that it's importing the JSON file. Notice that when you import a JSON file, you do have to put the extension there. It's not implied. We're importing the to-do item, and I'm iterating in a UL. I'm iterating over the to-dos array, right? And here's the to-do object, each one of the objects in here. So there's 1, 2, 3 objects. So it's iterating over each one, and then passing it, I am returning the to-do item. And the to-do item is going to render as an LI, right? So the UL is going to end up with just a whole bunch of LIs, right? So there's going to be an array of what? An array of to-do items, which each one is really a line item. See that? So this is going to end up with just be a UL, right, with a whole bunch of line items in here rendered, right? Now, notice what the to-do item is doing, right? We are passing the to-do object into the to-do item function, right, as an attribute. See that? So this is basically using that function, right, that is expecting a property called to do that I am passing as a value the to do that we're iterating over the map, the array, right? So the to do item is taking each one of those to do objects and extracting the title, the status, and the done flag, right, to render an input field, the checkbox, the title of to do, the line item, right, and then rendering all inside of a UL, right? So let's bring that into our lab 3, right, the to-do list, right? So this will be to-do list, and which renders as 3 line items, right? That list group, right, and with check boxes, the title, and the status, right? So again, this is only a sneak preview of what we're going to be using React.js for, right? Rendering user interfaces, form elements, checkboxes, input fields, and whatnot. Okay. All right. So another feature of the JavaScript language that we didn't get to play around in the slides is the spread operator, right? Also very, very powerful syntax, right? That works with arrays and objects, right? And so let's take a look at spreading, and let's create here spreading.tsx, and let's take in the function implementation. Let's take a look at this, right? So spreading is a new syntax in the ES6 version of the language, right? That allows you to take objects and copy them or spread them, right, onto new objects, right, to create bigger objects, right? Same thing with arrays. It allows you to take arrays and spread them or copy them into other arrays, right, to combine them to create bigger arrays, right? So let's take a look at an example. So here we have an array 1 that has 1, 2, 3, and then you have array 2, which declares it has its own properties 4, 5, 6. But notice that we are using this spreader operator to copy array 1 at the beginning of array 2. See that? This allows you to just grab the first 3 values here, array 1, right, and just copy them over, right, into array 2. See that? So this is literally as if I would have just copied this like this, right, and pasted it right there. Yeah, right. But certainly, if this were hundreds of items, I won't want to do one at a time, right? I can just spread it and copy it. Now this works also with objects. Now in arrays, the position of the items matters, right? Whereas in objects, the position does not matter. Well, it does matter a little bit. Let's see. Here we have an object with A, B, and C, 1, 2, 3. And here we are spreading object 1 onto object 2. So object 2 ends up with what? A1, B2, C3 plus, right, D4, E5, F6. And that's fine, right? That makes sense, okay? But what if I spray object 1 onto object 3, but object 3 already contains a B value? I notice that I am spreading object 1, which also contains a B value. So now there's going to be a kind of like a collision, right? There's going to be two B's. That can't be, right? No pun intended. And so, so this new object needs to decide, what do I do with a collision? I can't have two B's. So the way it resolves this is that it keeps the last one. Last one wins. So if this one copied, A1, B2, C3, then the next B is going to override the B2. So I would end up with A1, C3, B4. Okay. And so we can validate that in here. So we can just bring that in into the lab spreading. So spreading. And as we can see here, right, indeed, we end up with the later B4, right? Here we end up with the first one, object 1, right? That one with A1, B2, C3, and then we have B2, object 2, right? Is a combination of object 1 plus the ones that we're declaring at the end, right? And arrays, same thing, right? Make sense? All right, destructing, I'm going to leave that to you. You work on that, destructing functions and imports, and then we'll continue with this assignment later in the week. Okay.